Hello, welcome. Today we are going to be looking at electromagnetic induction. Electromagnetic induction is the phenomenon whereby electric current is produced by using a magnet and magnetic field in the absence of a battery. So this phenomenon is known as electromagnetic induction. Production of electric current using a magnet and magnetic field in the absence of battery. This is actually what happens when you use people like in the Kainji Dam where they are generating electricity for us. There is always this electromagnetic induction. Now we look at the Faraday's law of electromagnetic induction, which states that the induced electromotive force EMF in a circuit is directly proportional to the rate of change of magnetic flux or field lines linking the coils. So we know that electric current or electromotive force is actually produced by the changing of the magnetic flux in between the magnets. That is what electromagnetism is all about. So Faraday is telling us that the induced electromotive force EMF in a circuit is directly proportional to the rate of change of magnetic flux or field lines linking the coil. When we talk about coil, we're talking about the magnetic coil. Now, what are the factors that affect the magnitude of the induced EMF or current? What are the factors that affect it? Now, the induced EMF or current depends on one, the strength of the magnet. Two, the more powerful the magnet is, the more the number of field lines linking the coil or circuit. The speed of the magnet when coil is steady, or that of coil when magnet is steady. Very, very important. The speed of the magnet vis-a-vis the coil is very important in determining the amount of the EMF or current produced in electromagnetic induction. Another factor is the number of turns in the coil. There has to be enough turns in the coil. And this is so because as the number of turns of coil increases, the induced EMF also increases. So the three factors that we've looked at is the strength of the magnet, one, the speed of the magnet when the coil is steady, or that of the coil when the magnet is steady too, and number three, the number of turns in the coil. So those are the three factors that determine the magnitude of the induced EMF or current. Now let's look at Lenz law. Lenz law states that the induced current flows. This very induced current that you produce in electromagnetic induction, the Lenz law is stating that it flows in such a direction as to oppose the change producing it. That very change in magnetic flux that is producing it, the direction is opposite to the direction of the current produced. This Lenz law helps in identifying the direction of an induced current. The law is of positive use in the principle of the speedometer. Note the induced current, which tends to stop the rotation of the metal disc placed in a magnetic field is called eddy current. Eddy current is that very induced current which tends to stop the rotation of a metal disc placed in a magnetic field. AC and DC generation. To obtain an alternating current, whenever you hear the word AC, it means alternating current, whereas when you hear the word DC, it means direct current. To obtain alternating current, an AC is generated by connecting the coil to the resistance or load by means of two slip rings. The alternating current produced reverses the same way as the alternating EMF. Note, an AC generator is called alternator. So the diagram shows this very coil being separated by the carbon brush and the split rings. To obtain direct current is produced by connecting coil to an external resistance or load by split rings called commutators. The rings helps to reverse the connection to the external resistance in every half turn of the coil so that the current produced flows through the coil in the same direction. So that is actually what is explained here. Now we're going to be looking at the advantages of AC and DC. Let's take for AC or alternating current. It can easily be changed from one voltage to another with little loss of energy, unlike the DC. That is the advantage of AC. It is easy to change it from one voltage to the other. So when you're working on transmission lines, like for NEPA, they like working with AC until it gets to the house because you can easily step down or step up the voltages. For DC, it is most suitable in charging an accumulator. So use DC to charge if you want to save your energy. Eddy current. Eddy current, we are going to be looking at this now. If the laminated soft iron core of a dynamo were to be a solid block of metal that induced current in it, then it would absorb the power by opposing the rotation of the armature. This power will then be dissipated in form of heat. The induced current, which according to Lenz Law opposes the motion of the coil in a magnetic field, is called eddy current. What are the uses of this eddy current? Eddy current can be made use of in 1. Dampening a galvanometer. This process is used to bring the pointer more rapidly to a stop when current is passed through it, because in the absence of dampening, it takes the pointer a much longer time to come to its final steady deflection angle. Eddy current can also be used in the principle applied. The principle applied is to wind the coil on a metal so that as the coil swings, the permanent magnet induces an eddy current which then opposes the motion and subsequently shows the turning of the coil towards the required position. Can also be used in speedometers where the magnetic reaction of the eddy current sets up a couple on the pivoted aluminum disc which varies with the speed of the car, thereby enabling the opposing couple of the hairspring of the pointer attached to the disc to aid the pointer to indicate the appropriate speed. Induction furnace, where the rapidly changing magnetic flux through the metal in the crucible induces eddy current in it. When an alternating current of high frequency is passed through the coil surrounding the crucible, the internal energy produced as a result of the eddy current melts the metal. It is also used in detecting invisible cracks on railroad, which may be of danger to life. The detective device known as crack detector probe has a coil carrying an alternating current that sets up the eddy current around the area it is passed. So in subsequent classes, we are going to be looking at transformer and other things. Please, if you like this video, hit the subscribe button. If you have any questions and concerns, drop it on the comment section. If you want to contact us, please check out the description part of this video. Please like and share our videos, subscribe. Thank you, and God bless you.